Okay, students, so we have seen till now the fabrication for BJT, the bipolar junction transistor. Okay, now the next topic is about layout design rules. Okay, so there are some rules defined by the foundries or the manufacturing companies, which says uh, this is a set of parameters, set of defined rules that will tell about the actual spacing or the width of interconnects, the width of wires and the width of various components that could be fabricated on the IC. Okay, so basically this is all in terms of some sort of geometry. Okay, now geometry will be having uh, all the geometries of different components will be having different kinds of shapes, different kinds of sizes. Okay, so what should be the size, what should be the minimum thickness, what should be the minimum spacing between different components, what should be the minimum spacing between the components and you know by a passing interconnect. These kind of things, these kind of rules are actually defined under this heading, layout design rules. Okay, so basically it is a set of rules or prescription for preparing the photo masks, right? Because why photo mask? Because photo masks are the things that contain the actual geometrical shape, and from photo mask it is transferred on the top of wafer. We have already seen this process in the fabrication, CMOS fabrication. Okay, with the help of UV or optical lithography, we have seen those steps. Okay, so layout design rules are a set of rules or prescription for preparing the photo masks that are used in fabrication of ICs. Okay, so and what is the importance is that it provides a link between circuit designer and process engineer during manufacturing phase. Okay, so there is someone called circuit designer, and there is one someone called process designer. Now the circuit designer is working on the circuit, the designing, testing and of the circuits, and process designer will work on the actual fabrication of the circuits of the ICs. Okay, now when a person is actually involved in the fabrication of IC, he knows about all the things that is to be tackled, at the inside the manufacturing or fabrication unit. Okay, but he may not be knowing about the circuit behavior or the circuit various parameters of the circuits, or those kind of things. Okay, so he will have to connect to circuit designer all the time, in case if he needs to know something about the circuit that he is involved in the fabrication of. Okay, so one way that this information from where he can get is if this one is the layout design rules. So this acts as a bridge. The layout design rules act as a bridge between circuit designer and the process designer. So it tries to fill up the gap between these two different engineers, different types of engineers working. One is working in front end and the other one is working in back end process. Okay, so here we can see layout design rules, a set of geometric constraints or rules which are generally called layout design rules, right? So these rules usually specify the minimum allowable line width for physical objects on chip, such as metal and polysilicon interconnects or diffusion areas, minimum feature dimensions and minimum allowable separations between two such features. Okay, so it will give us what should be the minimum thickness of the interconnects, of the line widths, okay, of the components, of the gate, what should be the minimum width of the transistor. Okay, so such as metal and polysilicon interconnects, the wires, metal wires and polysilicon wires, or diffusion areas, the active areas. There is one term called as minimum feature dimension. Okay, one of the things would be smallest in dimension on the chip. Okay, what is that thing? That particular parameter is called as the minimum feature dimension. Okay, and it is generally I'm not saying all the time, it is generally the gate length of mm, the transistor. Okay, that is generally the minimum that is generally is of the minimum dimension on the whole IC. And what is the minimum allowable separation between two such features? Okay, so like these kind of things are being defined under a category, and these categories or rules are called as layout design rules. Okay, so what the main objective of the design rules is to achieve for any circuit to be manufactured with a particular process. Again, the process here is the fabrication process, a high overall yield and reliability while using the smallest possible silicon area. Okay, we want high yield, we want high number of working chips to be coming out from all the chips which are being produced. Okay, and they should be of high reliability, they should work reliably for a long period of time. Okay, and they should consume as small as area as possible. Okay, so these are the main things objective, and keeping these things in mind, the layout design rules uh, are formulated. Okay, and mind it, the layout design rules may be different for different kinds of process. Okay, suppose it may be different from for a 90 nanometer process, it may be different for 180 nanometer process, it may be a different for 14 nanometer process. Okay, so depending on the process, the layout design rules may vary. Okay, right. So but all the things we want in our favor, reliability, yield, and small consumption of area, but it is not possible to achieve all the goals at the same time. So what is there? Actually, practically we have a trade-off between these parameters. Okay, so there is usually a trade-off between higher yield, which is obtained through conservative geometries, and better area efficiency. Okay, so if the yield is high, if the number of components coming working components coming out are high, then in those cases there may not be there may not be efficient use of area available on the chip. Okay, and vice versa. Okay, and better area efficiency is obtained through aggressive high density placement of various features on the chip. Okay, so you should be clear that what do you want, whether you want higher yield. If you want higher yield, then in those cases you will have to sacrifice some area on the chip. Okay, and you will go with the conservative geometries. Okay, and if you want a densely packed IC, then in that case the better area efficiency would be obtained with some aggressive and high density placement of various features on the chip. Okay, and basically there are two types of layout design rules. The first is micron layout design rules. Okay, and the second is lambda rules. Right, now in micron rules, all these parameters, all these features such as minimum feature size and minimum allowable features separations, all these things are stated in terms of absolute values, absolute dimensions. Okay, for example, it may be stated that the minimum dimension should be, uh, let's say the minimum feature should be 10 nanometer. Okay, the separation should be at least 50 nanometer. So whatever, I'm just giving examples. So these parameters would be described in terms of actual numbers, actual absolute numbers. Okay,